Dear students, welcome to our class on JRF, SRF, NET 2022, Agricultural Meteorology, Advances 7. So, in this class, we try to understand the possible bits from the chapter Atmospheric Boundary Layer. Atmospheric Boundary Layer in most of the books, either European books or American books or even Australian books also, you will find ABL. It is the abbreviated form of atmospheric boundary layer. In all these books, the atmospheric boundary layer is defined from those locations where the authors have worked on the atmospheric boundary layer. For example, in the definition of atmospheric boundary layer, those authors that have worked in the temperate regions of the world, so they give the height, the layers of the atmospheric boundary layer slightly differing from those who worked in the tropical regions. And northern hemisphere and southern hemisphere. Say in the southern hemisphere, those books that were written by Australian scientists, they have defined the boundary layer and the phenomena that are occurring with reference to momentum flux, mass flux, and heat flux. Basically, okay, slightly differing from those authors from temperate region. Similarly, with reference to North American, that is United States of American authors. So here, I would like to impress upon you that the basic definition of atmospheric boundary layer may come in the form of a bit or two or assertion and reasoning type. Okay, the first thing is by definition, okay, atmospheric boundary layer ABL. By definition, the lowest 1 to 2 kilometers of the troposphere, which is directly affected by the underlying surface, is known as atmospheric boundary layer. What exactly does it mean? Troposphere. As far as the height of the troposphere itself is concerned, the average height is 14 kilometers over the tropical regions. Over the polar region, the average height is 7 kilometers, or troposphere. In the troposphere, what happens? As the height increases, the temperature goes on decreasing. Now, so atmospheric boundary layer definitions of all others revolves around the troposphere height. So, 1 to 2 kilometers from the surface of the earth is known as atmospheric boundary layer. However, in temperate region it is confined to only 1 kilometer height. It's not 1 to 2. So that difference you should understand. Now, what are the basic characteristic features of the atmospheric boundary layer? Basic characteristics. Whether it is temperate zone or whether it is tropical zone or whether it is the southern hemisphere or in the northern hemisphere, basically in all books that is available only, I am sharing that information with you. Now, the basic characteristic features of atmospheric boundary layer, irrespective of the region, are number one, the atmospheric boundary layer responds on time scale of few hours to maybe half day. Few hours to half day. For what? Atmospheric boundary layer responds to from few hours, 1 or 2 hours to maybe 12 hours to what? Surface forcings. What is surface forcing? Let us go back half minute before what I told. Definition of atmospheric boundary layer. Okay, the lowest 1 to 2 kilometers of troposphere, which is directly affected by underlying surface. So now, the first basic characteristic feature is with reference to underlying surface. the underlying surface, what it how it affects the atmosphere now, how it affects the atmosphere by the frictional drag exerted by surface, the frictional drag effect exerted by the surface on the flow of air. First, frictional drag means a resistance, frictional resistance offered by the surface layer, number one. Number two, evaporation and heat transfer. Evaporation and heat transfer. Transfer of pollutants, okay, and orographic effects on the flow of the air. So basically there are four phenomena, okay, or four types of drag is exerted by the surface layer. What is surface layer of the earth? On what? Airflow. The first one is the frictional drag. DRAG. Frictional drag means the frictional resistance. Frictional resistance. Number two, evaporation. Number three, heat and mass transfer. Number four, transfer of pollutants. This is the first characteristic feature of the atmospheric boundary layer. This may come in any form in the bits. Now, second thing, the boundary layer is a turbulent region during the daytime in which momentum and passive constituents like water vapor are transported by turbulent motions of air known as eddies. The term eddies comes in the atmospheric boundary layer. Why? Because second characteristic, the boundary layer is a turbulent region. Atmospheric boundary layer is a turbulent region during the daytime, in which momentum and passive constituents like water vapor are transported by turbulent motions of the eddies. So this is the second characteristic. The third characteristic is the turbulence is generated mechanically. The turbulence is generated by mechanically by what? Half minute back I told. So the frictional drag, the evaporation, the heat and mass and heat transfer, whatnot, everything. Okay, evaporation itself is a mass transfer. Okay, fixed law of diffusion, evaporation from a water body, we call it as a diffusion. Fixed law of diffusion, we explained it in the class number 6 and even 5 also somewhere we discussed it. Now, so third point is the turbulence is generated mechanically by the disturbances on the surface airflow, by the roughness of the surface, and by the drag means resistance which the surface exerts on the boundary layer airflow, which manifests itself as shear stresses. These are all the shear stresses. Suppose these papers are there. What is the shear stress? If I move the papers like this and if one side I hold it, this will come back. If I just move it like this by force from this side, so what is shear stress? It will move, but it will come back to the normal position if it is a bound. So that is the shear stress. Similarly, okay, the surface exerts on the boundary layer airflow, which manifests itself as a shear stresses. That's all. Now, the conditions of the surface heating during a daytime, the conditions of the surface heating turbulence is also generated by the buoyancy of particles of air which are heated by contact with the ground. So, there are some buoyant forces which are generated by the surface layer because of the air flow. So these are the basic fundamental characteristics of atmospheric boundary layer. So the boundary, this bit will come. Please understand, the boundary layer is composed of three main regions. The boundary layer is composed of, just to avoid any confusion, I would like to impress upon you that if you take a cycle of 24 hours, okay, 24 hours cycle if you take, and if you observe the atmospheric boundary layer, which is the atmospheric boundary layer in general 1 to 2 kilometers on the surface of the earth in the troposphere. So how it changes? The changes are basically accepted, scientifically proved three layers you will find. So the basic three main regions, in other words. There are three major regions that you find in 24 hours in the atmospheric boundary layer from 6 a.m. today to tomorrow 6 a.m. What are those? Number one, a well-mixed layer, the residual layer, the stable boundary layer. These are the three things that you will get in the exam. Now, the boundary layer is composed of three regions, 24 hours, same, where Radha Krishnamurthy is teaching to you, today morning 6 to tomorrow morning 6 a.m. So, atmospheric layer, where I am, there are three regions that I experience in the boundary layer. Number one is the well-mixed region I experience here. Then the residual layer I experience it here, and a stable boundary layer also I experience. So what are the characteristic features of these three layers? Mixed layer, residual layer, and stable boundary layer. Now, the bottom of the daytime boundary layer, occupying 10% of the layer, is surface or constant flux layer. First, where I am standing is the constant flux layer or surface layer. This may come 10%, 1 to 2 kilometers in that 10%, where I am standing is called as surface or constant flux rate. Constant flux means, constant flow. Flux is flow, but we give units. So that's why vector quantity, flux. It is not scalar, it is a vector quantity. Quantity and the direction we give. So it is a constant layer. First region is the constant flux region. So in this surface region, otherwise, the influence of ground is strong, because I am on the first 10% of the 1 to 2 kilometers depending upon the regions, atmospheric boundary layer. In that, the first 10% of the layer we call it as the surface or constant flux. In this surface layer, the influence of ground is very, very strong, and fluxes of momentum, mass and heat are large, reasonably with height. Here I would like to impress upon you the surface layer or constant flux layer is 10% of the atmospheric boundary layer. This may come in any form in the bits. Please remember that you should write perfectly. Now, in this surface or constant flux layer, what happens? The influence of ground is strong. That much you remember. As far as fluxes are concerned with respect to momentum, mass and heat fluxes, these are large in the surface layer. So by definition, how we define the surface layer or constant flux layer? Definition: the region in which surface fluxes vary by 10% and is therefore often referred to as the constant flux layer. This may come in the form of it in any direction. Now, see the mixed layer. The next one is the mixed layer. The mixed layer is the region above the surface layer. 10% of the 1 to 2 kilometers is the surface layer. It is known as constant flux layer, which may come in any form. The mixed layer is the region above the surface layer in which heat, moisture, momentum and pollutants are mixed uniformly in the vertical direction by eddies, EDDIES. In this mixed layer, all the momentum, mass and heat, all these three are mixed thoroughly. That's why it is known as mixed layer. Now, in this layer, the eddies assume uniform mixing of properties of a boundary layer and are usually driven convectively. This bit will come. They are driven convectively by solar heating of the ground and the size of the eddies, and hence the mixed layer grows during the course of the day. A stable layer, surface layer, it grows into a mixed layer as the day passes. 6 a.m., 7, 8, 9, 10, like that, it passes. As the day approaches, the day progresses, the mixed layer is formed. Now, the boundary layer grows. Next one is the boundary layer. As I said, the boundary layer is there. The stable boundary layer, that's what we call it as the boundary layer grows warmer and drier warmer and drier air is entrained into the boundary layer. Therefore, the inversion layer is sometimes known as entrainment zone. Inversion layer is known as the entrainment zone. Now, at dusk, that means during the sunset, the boundary layer collapses as the convectively driven eddies decay. Now, the boundary layer, which is developed from as the sun goes on giving the energy, the surface or constant flux layer is changed slowly into mixed layer, and the boundary layer, next one, next level. So these two collapse once the sun sets occurs, and then after the sunset, because the convectively, the dense boundary layer collapses as convectively driven eddies decay. Eddies take full shape during the daytime. Sun's energy is there. Eddies goes on decaying, and it becomes to ground level. So here I would like to impress upon you that there is a laminar flow, there is a turbulent flow, there is a constant flow. So to define how the laminar flow is taking into the shape of turbulent layer, these are all explained by two non-dimensional numbers, Richardson number, Reynolds number. So that's what we discussed in the class number 6. So this is what I would like to share with you. These things would appear in the form of bits in any way. We meet in our next class. Thanking you very much for your very patient hearing.